Howdy.
Howdy.
This is MXET 300, Group 6 of the Fall 2024 semester, and this is our final project presentation video.
So all of our deliverables were met by the end of the project, which include a 3D printed Ackerman steering mechanism and a custom 3D printed LiDAR and camera mount. The scuttle also uses Ackerman steering equations to convert steering angle values to rear wheel speeds. The LiDAR is used to dictate driving within a 3D printed lane and for obstacle avoidance of stationary and dynamic objects. And lastly, computer vision is used to detect the color of a small-scale traffic light, and the scuttle behaves as a legally operating vehicle would at a stoplight.
While not originally part of our scope, in order to account for a few physical and software-based limitations of our system, we also included 3-point turns into the robot's system. For the obstacle avoidance and pathing, the robot was asked and designed to essentially look to the left and look to the right with the LiDAR. And it would take the distance or the difference between the left and the right measurement values, and it would set that distance as or that resulting difference as the instantaneous center of rotation. So that way it would decide to turn left or right. It would then take that measurement along with other measurements of just the overall robot's dimensions and use them to determine the Ackerman steering equations used to calculate the wheel angles, and then the steering angle for the front end of the robot with the servo-controlled steering mechanism. And then if the LiDAR would detect obstacles in front of it or too close to the front of the drivetrain itself, it would attempt to use a 3-point turn in order to avoid it.
As for the stoplight behavior, computer vision was used. So a script was done to detect the stoplight green and red HSV values. And once this was achieved, the code was written to send a state to return a state, either go for green or stop for red. And if no light is detected, it would wait in the previous state. All of this was on the software side, while on the mechanical, it was just to design the mount for the camera in CAD, and that will be 3D printed and mounted on.
The physical design of the robot was relatively unchanged from our initial proposal, where we have a single servo controlling the steering of 2 front wheels. And then on the front of the robot, we have the LiDAR mounted upside down for detecting the lane, as well as a camera mount on the front of the robot so it has an unobstructed view of the stoplights. One physical modification we did need to make compared to CAD was to move the front wheels and servo linkage back on the robot by 20 millimeters because we found that the LiDAR would just barely clip the front wheel pods when looking left and right to get the wall distances. There were many parts involved in making this project. So for one, we have the wheels and wheels pods. Those are 2 of each part. So the wheels themselves, all 3D printed. The tires on the wheels were 3D printed out of TPU to make sure they had enough grip to actually have some authority over the robot steering control, as well as all the linkage parts involved with the servo control. We did have some hardware components, including some bushings, shaft collars, and the servo itself for the steering on the robot. Outside of the robot, we also used 3D printing to make the caution tape holding pylons, and the stoplight itself involved 4 different 3D printed parts. So we were able to maintain pretty much our expected work distribution as well as our timeline. We did have enough margin, so basically no one needed to work on anything over Thanksgiving break. So we ate into our week margin a little bit during that, but we maintained a fairly linear development process. We had some parallel development with the CV in combination with the lane keeping programming. So we were able to make good, efficient use of our time. And then we are all able to tune and test it for our demo video together. I personally was on the mechanical side of things. I designed the robot linkage in CAD as well as did the project planning and management for this final project.
And I was in charge of managing the mathematics side of things, specifically with the lane keeping and the Ackerman steering virtual differential. So basically that just included all the detecting left, right, figuring out where to turn, figuring out how to stay inside of the lane, and including the implementation of the 3-point turn.
So I helped James with the lane keeping and obstacle avoidance scripts, and I also helped Roberto with the stoplight computer vision programming. And on top of that, we also had to implement threading so that the computer vision script and the main driving loop could run concurrently.
Yeah, and as Skylar mentioned, I helped out with the stoplight computer vision behavior, and we all worked together with the proposal and the tuning and testing.
All right. Thank you. We hope you enjoy
Thank
our
you.
demo video.
Thank you.